As we review transformation in preparation for our assessment, let's think about some of the things that we've learned over these last couple of days and weeks. We talked about the idea of rigid transformation, and we had cut out different shapes and we transformed those, either doing the rotation, reflection, or translation. So this is what you should be able to do is triangle PQR is rotated 270 degrees about the origin. Graph and label the coordinates P prime, Q prime, and R prime. So one, you need to know what rotating means and where you need to rotate it about. So it's the origin. So part of your mathematical practice one, I expect to see you highlighting where, by how much, and what do you have to do. So this little phrase right here should be highlighted so that you could do your next step. So then you will actually do it. And you should come up with that. And great, many of you know exactly what to do. So that's a rotation. That's knowing that it's going to move the points about the origin and by how much, the degrees. Is it 270, 190, 90 degrees? That's what you have to notice. Mm-hmm. Then the next part, here's another example where it talks about the quadrilateral P prime, Q prime, R prime, S prime is the image of the quadrilateral PQRS after a translation. So remember what a translation is? That we're going to just move the quadrilateral. So if the length of the side PQ, which is right here, the length of this side PQ is 2.8 units, what is the length of the side P prime Q prime? Well, based on what we've been looking at when we were cutting out those images and we had that coordinate plane and we were doing all these different translations, some of the patterns that you all talked about was that it's congruent, that the sides are the same, the angles are the same, the shape is the same. So if all those things are the same, then the length of side P prime Q prime has to be the same, which is 2.8 units, because of what we already studied as we were doing our manipulation of different shapes through a translation. And additionally, so part B says if the measure of angle R is equal to 75 degrees, what is the measure of angle R prime? Well, again, if we already know that that is congruent, that the two quadrilaterals are congruent, then I know that the measure of R is equal to the measure of R prime. And you all saw that, and we were able to prove that that pattern does exist over and over again. So it's true. And there is the answer to your paper. Okay. The next one, let's look at this example that you will have to know. So we already know what rotation, reflection, and translation is. And now this question asks, describe a sequence of transformations that maps triangle QRS onto triangle TUV. So before you even get ready to start, what do they mean onto? It has to be right on top of each other. And we, again, going back to earlier lessons, we did that. So a translation of blank units to the left and blank units down, followed by a blank cross the blank. That's what we have to figure out. And what you notice is that the translation 3 units to the left and 4 units down, followed by a reflection across the y-axis. That explains that that transformation. And we know that those two shapes are congruent. And we've been talking about similarity and congruency over and over through the course of our work. But then when we look at translation, reflection, and rotation, we know that the shapes are congruent, and we saw that. But then when we added in dilation, which is a transformation, we saw that there was another concept. It wasn't quite congruent, but they were similar. And that's this problem here. Well, we know that RSTU and VXYZ are quadrilaterals. So given that RSTU and VXYZ describe a sequence of transformation that maps out RSTU to VXYZ. And the first thing we can see is that it's a reflection across this y-axis, and it moves, it's a translation 3 units to the left and 3 units down from the original point. The dilation with the center of the origin, which is 0, 0, and a scale factor of 1/3. So this, we scaled down, the dilation went down to a scale factor of 1/3, this image. And once you know all of those relationships, you are ready. Any questions?